So in 9.1, we start looking at equations in two variables. So here's an example. This is actually a linear equation, the equation of a line, in the two variables x and y. But first example just starts by looking at plotting points. So here I have an xy pair. So remember, when I write a pair like 1, 2, the first coordinate is the x, the second coordinate is the y. So if I plot that point, I go 1 unit on the x-axis, 2 units on the y-axis. And that's where that point 1, 2 lies. So here it also asks, in which quadrant does the point lie? So here's quadrant 1, here's quadrant 2, quadrant 3, and quadrant 4. So I plotted that point. It lies in quadrant 1. Let's do number 2. So the x is -3. The y is +1. Left 3 and up 1. So that point lies in quadrant 2. Number 3. The x is -2. The y is -3. Left 2 and down 3. And that guy lies in quadrant 3. Next one. The x is 1/2. The y is -2. Right 1/2, down 2. That guy is in quadrant 4. Last one. The x is 0. The y is -4. So we don't go left to right, but we just go down 4. So that guy is not actually in a quadrant. So I would say it's actually on the y-axis. Okay. Next one. Does each ordered pair, so does each xy pair satisfy the given equation? So here's the equation. Here's my xy pair. So what I'm going to do is I'm going to plug the x value and the y value into the equation. And I'm going to see, do I get 0? So let's see. Well, I can cancel the 4 and the 4. First term would leave me a -3. Cancel the 2's, plus a 3. So I get a 0. Okay? So yes, that means this ordered pair does satisfy the equation. So graphically what this means is that means this point is actually on the graph of the line given by this equation. Now we're going to talk in a little bit about actually graphing lines, but that's what that's telling me graphically. So let me try the next part. So it's the same thing. The question is, does the ordered pair satisfy? We're still looking at the same equation. So I'd give it a try. So 3/4, the x value is 1, plus 2, the y value -3/2. I'm simplifying, and the question again is, do I get 0? Because that's what's on the right side. So 3/4, 2's cancel, minus 3. LCD. It's -9/4, so that is not 0. So my conclusion is no. The ordered pair does not satisfy the equation. So what that means graphically is that point is not on the graph of that line. Find the missing coordinate. Okay, so here's the equation, linear equation. Y equals 5x minus 4. You see what I'm given here? I'm given the y coordinate. So I need to solve for the missing x coordinate. So let me put that y coordinate in, and then let me solve for x. (35 divided by 5 is 7. So the missing coordinate is 7. So if I wanted to actually write out the pair, the point on that line would be 7, 31. Here we're interested in the same equation. We know the x. So we're solving this time for y. Okay, so the y is -6. So the point on that line would be -2/5, -6. Here's another example. This is kind of a special one. So let me look back at what the instructions were. Same instructions. Find the missing coordinate. But this time the equation is just y equals -1. So actually, doesn't that mean that no matter what the x is, the y is just -1? This is an easy one. So this is a special kind of line. And we're going to talk about this kind of line where I'm only given the line in terms of one variable. It's actually a horizontal line. But we're going to get to that in a couple sections here. Use the equation 4a over 3 plus 2b over 5 equals -1 to complete the table. So like, first example, they're giving me a value of b. So let me see. So in the first column, I have to fill in a and a comma b. So I'm going to plug the b equals 0 in the equation. So let me do that. So 4a over 3 plus 2 times 0 over 5 equals -1. 2 times 0 is 0. 0 things divided by 5 people is 0. Multiply by 3. Divide by 4. A is -3/4. So we found the first piece of data. So my pair would look like so. Next one here, they're giving me a. So I put the a in there. Okay, so how would that look? 4 times, what was the a? 0 over 3 plus 2b over 3 is negative 1. 4 times 0 is 0, divided by 3 is 0. Multiply by 3. So b is negative 3 over 2. So this pair be 0, negative 3 over 2. Let's see, there's one more where I'm given the b. So I'm going to plug that in for b. The b is 10. Let me copy this. So I'm plugging in b is 10. So 4a over 3 plus 2 times 10 over 5 is negative 1. Let's see, 10 and 5 leaves 2. 2 times 2 is 4. Subtract the 4. Negative 5. Multiply by 3 and divide. And there's my point then. So what I did here graphically is I really just found 3 points that lie on the line given by this linear equation. We're going to talk about graphing those lines here in just a couple of sections. So let's take a look at actually graphing some of these linear equations we've been talking about. So here I have an example of a linear equation. So I can see the exponents here. We have powers of 1. So if I want to graph this by plotting points, that means I want to make a table of values. So maybe it would be useful first if I go ahead and solve the equation for y. Okay, so what I did there, I went ahead and subtracted the 5x on both sides. Then let me go ahead and divide by negative 2. Okay, now I'm going to make a table of values here. So let me maybe plug in, I can start with values, say, between negative 2 and 2, and then go from there. So let's see, I'm going to have 5 halves times negative 2 plus 5. So that'll be negative 5 plus 5, so 0. I need more room here, I think. Okay, what about negative 1? So negative 5 halves, and then 5 multiplied by 2 over 2, that's 10 halves. So 5 over 2. Five halves times 1 plus 5 So again, I multiply by 2 over 2. Okay, so let me look at these points that I found. So from the first column, the x is -2, the y is 0. So the point that I actually found there is -2, 0. Next row, -1, 5 over 2. So 5/2 is 2.5. Zero, 5. One, 15 over 2. Let's see, 15 over 2 is what, 7.5? Because that's going to be way up. I mean, I'm drawing a line here, so I bet you, I mean, my next point's 210. Bet you I have enough here. In fact, if I have 2 points, if I know I'm graphing a line, I can actually draw that line in. And so there's that line. Okay, let me solve for y again. X over 3, or a third x. So again, I'm making a table. Now, I kind of think, since I have that 3 in there, what if I did something like this? Picked multiples of 3. That way I'll get nice numbers when I plug them in. Can always add to my table if I need to. So let's see, what are my points? -3, comma, -1. 0, 0, and 3, 1. And there's my line. So that's one idea for how to graph a line. I can do it by actually plotting points, as in making a table of values. Another idea is to find the intercepts. So the intercepts, let's say it this way actually. Let's say the intercepts are the points at which the graph crosses the x or y axis. Okay, in other words, they're points where the graph's either here on the y-axis or here on the x-axis. So let's see, let me look back at a couple of these other ones. So this guy has an x and y intercept at the origin. This guy, this would be a y-intercept because it's on the y-axis. This guy would be an x-intercept because it's on the x-axis. Okay, so if my goal is to find the intercept, so let me start with, say, the x-intercepts. Okay, so x-intercepts, I'm here on the x-axis. So the x has changed, but the y hasn't gone up or down. So I have to set the y then equal to 0, because that means I'm actually on the x-axis. So 4/3 x plus 0 equals 1. Divide. Okay, so the x-intercept is 3/4, comma 0. Okay, what about y-intercepts? Okay, so to find y-intercepts, I'm looking for places here on the y-axis. So on the y-axis, I haven't gone left or right. So I set the x equal to 0 to find points there. Okay, so that'd be 4/3 times 0 plus y is 1. Well, that one's easy. Y is 1. Okay, so I know I'm dealing with a line. Go ahead and draw a straight line through those points. And there we have it. Okay, let's do another one the same way. Set my y equal to 0. Divide. Two-thirds, 0. Okay, what about my y-intercept? Set x equal to 0. 2y minus 3 times 0 plus 2 is 0. Y is -1. And then connect the 2 points with a line. And there it is. Okay, so here I have a couple of special lines. So the thing is, this line here, it says x is always equal to 2. No matter what y is, x is equal to 2. No matter what y is, x is always 2. So I can pick any y value as long as the x is equal to 2. So look, here's 2, 1. Here's 2, 2. Here's 2, negative 5. So look at the line I'm going to get. So this is a special line. This guy's called a vertical line. That's a vertical line. So lines of the form x equals a number, those are vertical. They go up and down. Versus, I bet you can guess here, in number 2, this one's saying x can be anything. But y is always negative 1. So 1, negative 1, 2, negative 1, 5, negative 1, negative 3, negative 1. So where are these points? 1, negative 1, 2, negative 1, 5, negative 1, negative 3, negative 1. So this is the other special kind of line. This guy's called a horizontal line. Okay. So y equals a number. That's a horizontal line. Flat, like looking across the horizon.